All right, let's talk about the quotient rule next. So the quotient rule is if we take the derivative of a quotient of two functions, right? Of one function divided by another function. All right. And basically what we get is we get the derivative of the first, or the derivative of the numerator function, right, times the denominator function, minus the derivative of the denominator function times the numerator function, all over the denominator function squared, right? So it's similar to, and let's look at it this way here in terms of prime. It's maybe a little easier to kind of digest here. If we take f prime g minus g prime f, right? So it's almost the same exact function, or it's almost the same exact numerator as what the product rule is on its own, except it's a minus instead of a plus, right? So if you can just remember that the numerator is the same as the product rule, but with a minus, and on the bottom you divide by the second function squared, okay, or the denominator function squared. All right. So the way that I've heard this explained before, or one way to remember it, is to think of this as the high, and this is the low. And if this helps, use it. If it doesn't help, don't worry about it. But I've heard people say low d high, so in other words, the derivative of the high, so low d high minus high d low, so it's kind of backwards the way they write it here, over low. So low function times itself, right, is low squared. So that's not a minus, so we'll just say low. Okay, so low d high minus high d low over low. So that's one way to think of it. All right, so one way or the other, that is the quotient rule, and let's see it in use here. So we're using the quotient rule to find the derivative of this function here, and so we know that. Let me write it out here. So if we have the derivative of j prime of x, where j prime of x is f of x over g of x, then remember it's f prime g minus g prime f all over g squared. Okay. All right, so here let's call this f, and let's call this g. All right. So k prime of x is going to be f prime g minus g prime f all over g squared, right? And so let's find f prime. So f prime, so if this is f, then f prime will be 10x, right? And g prime, if this is g prime will just be 4. Okay, so f prime is 10x, so I'm going to put a 10x here. G is 4, so I'm going to put a 4 here. Or excuse me, that's g prime. G is 4x plus 3. Okay, and then minus, and then now we're on to g prime, which is this here. Right, and so we're going to put in 4, that's g prime, and then f is 5x squared. Then on the bottom, g squared is 4x, or g is 4x plus 3, so I'm just going to square that. All right, so now I'm going to simplify. So here I'm going to distribute, and here I'm just going to multiply these together, right? There's no distribution needed because those are monomials. So we have 40x squared, 10x times 4x, and then 10x times 3 is 30x, minus 4 times 5x squared is 20x squared. And then the bottom, we can just leave that like this. There's no There's no need to expand that because there's nothing we're adding or subtracting. So whereas here we're adding and subtracting these so we can combine like terms. Here that's not the case. We can just leave it as it is. So, oh, I forgot the squared here. All right, so now we have like terms, and so 40x squared and 20x squared, if we subtract, we get 20x squared plus 30x all over 4x plus 3 quantity squared. Okay, and that's basically it. That's our answer. If you want to factor the numerator, you can. Like that's not a bad idea because sometimes there's things you can cancel out when you factor. So like if I factor out a 10x, 10x is the greatest common factor, then I end up with 2x plus 3. And if that was 4x plus 3, we could actually do some canceling there, right? But it's not, so we're just stuck with this. Okay, so either way, you can express your answer like this or like this. It's good to check to see if you can cancel, but yeah, in this case, we can't do it.